Alrighty then. 3.1b. Solving quadratic equations by factoring. Okay, so there's 4 steps here, but this third step. Standard form, common factor, X box, solve. This step is gonna take a while right here. So let's get into it. Let me show you some stuff. Here's an equation. Okay, so the first things you want to do is in standard form. No, that's not in standard form. Okay, you want everything on one side of the equation. One side is going to be 0 and the other side is going to be something else. Okay, in standard form, one side of the equation will be 0. So for me, the variable in this case is x. The x squared is right there. X squared happens to be right there. Put it down there, we can see a little better there. Okay, in this case, the x squared is on this side and it's positive. I always want the x squared term to be positive. So since it's positive, I'm going to keep it here. If it was negative, then I'd put it on the other side of the equation. Okay, it's just easier. If your x squared term is positive, it makes things a lot easier. You make less mistakes. So I need to get this stuff over here. So the opposite of adding 12 is subtracting 12. And the opposite of minusing 48 is adding 48. So you do it to both sides, and it'll be in standard form. That is now in standard form. Okay. Next step is, can you get a common factor out of that? Excuse me, is there a common factor? Yes, there's a 2. You can factor out a 2. So you can factor out a 1, but anything other than 1. That is divisible by 2. That coefficient is divisible by 2, and that is divisible by 2. Okay, so I'm going to divide everything by 2, and when you do that, you get x squared minus 14x plus 24. That should be 24. I made a boo-boo. Okay, and keep in mind, when you divide by 2, the x-intercepts will be the same. Our answers are going to end up being the same, but if you graph this equation and graph that equation, the graphs will look different. Okay, here's an example right here. You can see that this graph right here, there we go. These two graphs are different. They have a different vertex, but they go through the exact same point. So if you zoom in, that, they still both go through 2, and they both still go through 12. Okay, the graphs do look different. So I did this common factor. I'm just doing this because when you work with small numbers, it's easier to work with. If you work with larger numbers, it's harder to work with. Okay, so next thing, X box. So I'm gonna make an X, and my box, there's my box right there. Okay, right here I'm gonna put A times C, and right here I'm gonna put B. So take this equation, rewrite it right there. In standard form, find the values of A, B, and C. Here's the values of A, B, and C. And according to this, A times C goes in that spot right there, and then the value of B goes in that spot right there. Okay. Well, what's the value of A times C? A times C is 24. The value of B goes in that spot. So B is negative 14. Right there is negative 14. Okay, negative 14. Now, we need to find two integers, not decimals, not fractions, but integers. Two integers, they're going to go here and here. When you multiply them, you get this, and when you add them, you get that. Two integers, when you multiply them, you get 24, and when you add them together, you get negative 14. Okay, 1 and 24, 1 times 24 gives me this, but it doesn't add to that. 2 times 12 gives 24, but 2 times 12, there we go, 2 times 12. 2 times 12 gives me 24, but 2 plus 12 gives me a positive 14. So we need to do this. Negative 2 times negative 12 is positive 24. Negative 2 plus negative 12 is negative 14. Boom. Good so far. There's the X part of the X box. Then you make your box and have 4 squares. In the square in the upper left, the first term, that term right there is going to go right there, x squared. The last term, that goes right there, 24. Then in these two spots, doesn't matter which one, so you get these two numbers that we just found go in this one and this one. You can go here and here, or you can do the converse and do it there. So -2 and -12. -2 and -12. Now, these two numbers, when you add them together, it should give you the middle term. Okay? Do these two, when you add them together, give you the middle term. Right now, when you add these two together, it gives you a -14. But we want a -14x, so we need to add that variable x there and there. Now these two will combine to give us a -14x. So now what we're going to do is we're going to do some multiplying two terms. What two terms, when you multiply them, gives you that? This term times that term gives you this. Happens to be x and x. X times x gives you that. Okay, this term times what term gives me that? This term times that term will give me a -2x. Happens to be a -2. That's a negative. Then these two. This term times the term right there will give me a -12. Happens to be -12. Now to double check your work, these ones here, this times this, okay, should give me that. That's what it should. -12 times a -2 gives me a +24. It works. Okay, so we are now going to take that quantity, x minus 12, put it in parentheses. Then we take this quantity, x minus 2, put it in parentheses, and remember, it's all this stuff equals 0, so don't forget that equals 0 part. Equals 0 equals 0. So this quantity times that quantity equals 0. Okay, now the zero product property rule on page 96, it states that if two expressions, the product of any two expressions is 0, then one or both of the expressions has to equal 0. So in algebra, if A and B are expressions and A times B equals 0, then either A has to be 0 or B has to be 0, or they both are. Blah, blah, blah. What does that mean? It means that junk has to be 0 or that junk has to be 0 or they both are. So to solve, you take this junk, you set it equal to 0, and you take that junk in the parentheses, set that also equal to 0. These two pieces of junk equals 0. So you set that equal to 0, and you set that stuff equal to 0. Now solve. Okay, this stuff you've done before. X, add 12 to both sides of the equation, and you get x equals 12. In this case, so you add the 2 to both sides of the equation, and you get x equals the 2. So your answer here is x equals 12 or x equals 2. Okay, that's what you get when you solve by factoring. So that, how do I know if that's right or not? I can always go back to the original problem and replace x with a 12. When x is 12, the left side of the equation should be the exact same as the right side equation. It does, because I've already checked. It should also say if x equals 2, it should also work in the equation. When we replace the value of x with the number 2, the left side of the equation should be the exact same as the right side equation. The value on the left side should be equal to the value on the right side. There it is right there. Okay. And let me show you another one right here. We go. Let me do move this out of the way. Okay. Put that in view. So what you want to do is in standard form. Not yet. Need to subtract 45 on both sides. B squared minus 4b minus 45 equals 0. Done. Is there a common factor? And that's a 1. When you got a 1 there, no, there's no common factor amongst all three terms. You're looking for a common factor amongst all three terms. And there, other than 1, there's nothing. So step B, you cannot do it. Step C, X box. X, make my box. Okay, A has a value of 1, B has a value of -4, C has a value of -45. What was here? It was, what was that thing that was in your notes? Look back at your notes. What was it? A times C, and that is B. A times C, 1 times that is -45. Okay, the value of B goes here. The value of B is -4. 1 times 45 gives me 40, but it doesn't add up to 4. 5 and 9. 9 and 5. 9 times 5 is 45. We want -45. And we want, when you add these, you get -4. So if we make this a -5, would that work? No, because 9 and a -5 would give us a +4. So let's put the negative over here. Now, is -9 times a +5 equal to -45? Yes. Is -9 plus 5 equal to -4? Yes. So that's good right there. Okay, in our box right here, the first term, v squared. That box right there is the very last term. And then these two empty boxes, these two terms go in the empty boxes. And remember, these -9, 5. These two terms have to add up to a -4 v. Don't forget the v. PV. In this case, the variable is v as in Victor. Okay. Now we need to take what two terms multiply to give me a v squared? V and v. So v times what gives me a -9v? -9. V times what gives me a 5v, a +5. So now we take this term, v plus 5, and we take that, v minus 9, multiply, and remember, all this stuff right here equals 0, equals 0. Okay, now if you wanted to see if this is actually, you can actually go through this and multiply these binomials, do the cat face, the first, outer, inner, last, FOIL method. When you multiply this chunk times that chunk, you're gonna get this stuff right here. It's just backwards way of doing it. Okay, so X box is done, X box is done, solve it. Oh, this chunk times that chunk equals 0. When any two pieces of junk equals 0, any 5 pieces of junk, when you multiply them, it gets 0. I don't care. Anything when you multiply a whole bunch of stuff and your answer is 0, then you set all those pieces of junk equal to 0. In this case, you got 1 piece, 2 pieces equals 0. Set that piece equal to 0. Set this piece equal to 0. And solve. Solve. V equals -5 and V equals +9. So our answer in this case is, how do I know if I'm correct on this or not? I go back and check my work. That's how you know. You don't need, hey, is this right? Let's find out. -5 squared, that's 25. -4 times a -5 gives me 20. So 25 plus 20 gives me 45. Bam, it works. What about a 9? 9 squared is 81. Negative 4 times 9 is 36. 81 minus 36 gives me 45. Bam, it works. So that's my answer. Put a nice little box around it, so when someone says, where's your answer? It's highlighted right there in the box. It's easy to see where your answer is. Okay, let me do one more example. Okay, now this stuff, this is done by factoring. Before we're doing stuff by graphing. Okay, that's just a different way of solving it. Right? This one is solving by factoring. Okay, so is it in standard form? No, it's not in standard form, so put it in standard form. Negative x squared plus 2x plus 3 equals 0. Okay, this term is negative. I normally don't like that, but it's the way it is. There's more mistakes when a is 0, so just keep that in mind. Okay, is there a common factor? There is not a common factor amongst all three of those. Nope, not. Okay, try the X box. Okay, a equals negative 1, b equals positive 2, c equals 3, X box. Okay, what goes here? What goes there? A times c goes right there. Negative 3. The value of b goes right here. What two integers multiply to give you a negative 3? And those same integers, when you add them together, you get 2. How about a 1 and a 3? 1 plus 3. 1 times 3 is, it's a we need negative. Can we put a negative here? No, we put a negative here. This times this gives us a negative 3. That works. This plus that gives me a positive 2. Ba-bam. Nice, so we got that. In this box is the very first term, the entire term, negative x squared. In this box right here is the entire last term, plus 3. And we take these two terms and put them in there and there. Okay, and when these two combine together, it should give us a positive 2x. In this case, the variable is x. So now we're saying what two terms, when you multiply them, gives you a negative x squared. See, here's where the negative comes in, right here. It just creates problems. This is where people make boo-boos. Okay, well, I know it's x and x. One of those is going to be negative. And to help out, is this a negative? No. Is that a negative? Yes. So let's make this row negative. I'll make that one negative. This times this is negative x squared. This times what gives me a positive 3x. It's a positive 3. This times what term gives me a negative x. It's a 1, positive 1. Okay, and to double check, is a positive 3 times a positive 1 equal to a positive 3? Yes. Sweet. So we're going to take that term, negative x plus 3, put it in parentheses. We take this term, x plus 1, put it in parentheses, and equals 0. Equals 0. Great, that part's done. Solve. Okay. The zero product property rule says if you're going to multiply things together and if your answer is 0, then either that stuff is 0 or that stuff has to equal 0. And solve for each one of those. The opposite of adding 3 is subtracting 3 on both sides of the equation. We're not done yet because we want x on that side. Right now we have a negative x. So a negative 1 times x, the opposite of negative 1 times x, is dividing by a negative 1 on both sides. And we get 3. In this case, the opposite of adding 1 is subtracting 1 on both sides of the equation. So x equals 3 or x equals negative 1. In college, they want you to write the smaller number first and then the larger number following that. For those of you interested in going to college, that's what they want. Okay. So these are my answers. How do I know that works? I can go back and check. Negative 1. So first I'm squaring the term first, then you multiply by negative. So negative 1 squared is a 1. Put a negative in front of it, you now have negative 1. 2 times negative 1 is negative 2. Negative 1 minus 2 gives me a negative 3. Boink, it works. What about when x is 3? 3 squared is 9. Stick a negative in front of it. 2 times 3 is 6, so we have 6 to it. Negative 9 plus 6 is a negative 3. Look at that. The left side of the equation equals the right side. Boink! This is correct. Okay? So there's 3 examples of solving by factoring. Okay? Good luck, guys. Bye.